This problem is about understanding the feel of standard deviation. Do not calculate the standard deviation on this problem, but try to apply the concept of standard deviation. So which of the below data sets has the lowest standard deviation? Lowest. Again, you do not need to calculate the exact standard deviation to answer this question. So it's all about, do you have a feel for what standard deviation is? Really, this is more important than calculation. Real life, you're probably never going to calculate a real standard deviation. Calculators do it. But you will read studies done, professional work that's done in which they do provide a standard deviation number. And so to operate professionally, you want to know what that means. What's the feel of it? Standard deviation is a measure of the spread it's the measure of the spread of data points. It's what it technically is. It's the average distance of the data points from the middle. That's what standard deviation. Remember, deviation means distance from the middle. You know, somebody that's a social deviant, that means their behavior is different than average. They act funny. So deviation means different than the middle, different than the normal. So standard deviation means average distance from the middle. So basically, if the data is more spread out, that means we're going to have a higher standard deviation. And if the data is less spread out, then we're going to have a lower standard deviation. So let's go look at the data and let's just put it on a number line. That'd be the easiest thing. If I was just to do a number line here, and I have to say, okay, we got, looks like 0 here, because we go from 0 all the way to, also put 200 right there. It's the highest number. So we have 1, 2, 3 numbers at 0. One of them that's right here at 100. And then 3 numbers at 200. That's pretty spread out data. Let's try the next one. So we'll do this one now. So for this data set, we start here at 0. We only go up to 6, so it's not very far. Let's go 1, 2, 3, 4, 5, 6. Doesn't matter that it's not spread out the same as the other, but just put it on there. So we have a dot at 0 here. 1, 2, 3, 4, 5, 6. We have a dot at 1. We have 3 dots at 3. 1, 2, 3. I'll just stack them. A dot at 5 and a dot at 6. That data is pretty clumped together, isn't it? Pretty clumped together. Let's try the, so that one definitely has a lower standard deviation. Let's try this next one down here. So I'm going to go same kind of thing. And go 0, 1, 2, 3, 4, 5. Let's try to space it just like the last one. And we just have 1 dot at each of those spots. 0, 1, 2, 3, 4, 5, 6. Okay. So now the last one, this data set down here, we'll go like that. We're going from 0 to 1,000. Wow. Okay. 0. This one's going to be more spread out clearly. So this is like 500 in the middle. This would be like 100, 200, 300, 400, 100, 200, 300, 400. So one of them is at 25, 50, 100. So we have 100. We have one number that'd be about 25 right there. 50, 125 right there. 150 halfway. And then like 1,000. Okay, so now we have these 4 data sets. Which one has, what do they want? They want the lowest standard deviation. So we want the lowest spread. Which data set is spread out the least? It's going to be this one. Do you see that? How three of them are clumped right there in the middle. And the furthest anybody is from the middle, that's 3 above the middle, and that is 3 below the middle, right? Because the middle's 3, and 0 is 3 below that, and 6 is 3 above that. And you might say, well, yeah, what about the green data set? Yeah, it's close. It's close. The middle is 3, and that's 3 above, and that's 3 below. I agree. But notice it has one that's 2 above and one that's 2 below. You think, well, this one also has a 2 above and a 2 below. Yep. But it doesn't have a 1 above and a 1 below. They're all clumped there. So that's more centralized, isn't it? So this data set is going to have the smallest. This one right here. Let me do this well. This is going to be the big winner here. Right there. He's going to have the smallest standard deviation because they are the least spread out. They're the most centralized. It was kind of close on those middle two. The top and the bottom one are way spread out. They have really large standard deviations. So there we go. That's the feel of standard deviation. So if you read a study, a professional study, and somebody talks about standard deviation, you know what it means. It means that the spread of the data, the average distance from the middle, how spread out the